Hey, this is Anag, and in this video, I'll be going over related rates. And the reason why I'm doing this is because related rates, I think, is a very important concept in lots of calculus classes, especially AP calculus, and it's crucial to know. So I hope that after watching this video, you feel more comfortable with this important concept. So what is related rates? Well, related rates is when we explore the relationship between two quantities as well as how those two quantities change with respect to a third variable. And to illustrate this concept, I'm going to use this equation over here, y equals x squared. So this is a pretty standard equation. We have y, and it's equal to x squared. But now let's say that x and y are both changing with respect to time. So what I'm going to do is I'm going to differentiate both sides with respect to time. So let's do that. So we have d dt of y, and that equals d over dt of x squared. D over dt of x squared. Let me just do that. Okay, so here's what we have. So now let's rewrite both sides. So the derivative of y with respect to time is just dy by dt, right? And then the derivative with respect to time of x squared, what we have to do is that we have to take the derivative of x squared with respect to x and then multiply that by the derivative of x with respect to t. That's the chain rule. So let's use a chain rule on this one. So this equals 2x times dx dt. And now let's take a look at what we have. We actually have a relationship between how y changes with respect to time as a function of the x value as well as the rate at which x changes with respect to time. And this kind of equation can be used to deduce important information. If we're given certain information, we can use this equation to figure out other values. So let's go ahead and do an example. So here I have a square, and let's say that each side length of the square is increasing at a rate of 4 units per second. So let me go ahead and write that. ds by dt is going to equal 4 units per second. All right? And now let's say that at a specific time instant, the side length is equal to, let's say the side length is equal to 8 units. At a specific instant in time, the side length is equal to 8 units. And now let's say I want to find at what rate the area of the square is changing at this specific instant in time. So what I want to find is I want to find what dA by dt is. I want to find what that is. So how do we do that? Well, the first thing I want to do is I want to express the area of the square as a function of the side length. So how do we do that? Well, we know that the area of a square is equal to its side length squared. Now, let's do this. Let's take the derivative of both sides of this equation with respect to t. So if we do that, the derivative with respect to time of area is just dA dt, which is what we want, and that is equal to the derivative of s squared with respect to t. So based on the above example, the one that we did just before, this is equal to 2s times ds dt. And now we're ready to find what dA dt is at the specific instant in time. We know that at the specific instant in time, s has a value of 8, and ds dt is at a constant 4 units per second, right? So this is equal to 2 times 8 times 4, which means that in all, that is 64 units squared per second. So what this means is at this specific time interval, the area of the square is increasing at 64 units squared per second. Let's go ahead and do another example. So here I have a circle and the circle has a radius r. So let's say that the radius of the circle is increasing at 2 units per second. Let's say that. Okay, let's say this radius of the circle, dr dt, is equal to 2 units per second. All right? The radius of the circle is increasing at 2 units per second. And let's say that at a specific instant in time, the area of the circle, let's say the area of the circle is increasing at, I don't know, let's say 8 pi units squared per second. So now here's what I want to find. So given this information, the radius is increasing at 2 units per second, and at a specific instant in time, the area with respect to time is also increasing at 8 pi units squared per second. Based on this information, I want to find what is the radius of the circle at this specific time interval. So, as always, the first thing we should do is that let's write an equation. So let's write an equation expressing the area of the circle as a function of the radius of the circle. So we know that the area of a circle is equal to pi r squared, right? That's a pretty standard geometry equation. So now let's do this. Let's differentiate both sides of this equation with respect to time. So the derivative of a is dA dt. That's the change of area with respect to time. And that is equal to the derivative of pi r squared. So the derivative of r squared is just 2r dr dt. And then pi is just a constant, so it just kind of tags along. So what this becomes, this will become 2 pi r times dr dt. And so now we have an equation. Now, given our information, dr dt equals 2, and dA dt is equal to 8 pi, let's figure out what r is. So we know that dA dt is equal to 8 pi, so let's write that there. 8 pi, and that is going to equal 2 pi times r, and r is what we're looking for. R is what we're looking for, and then we know that dr dt is equal to 2. So let's go ahead and solve for r. So r would be equal to 8 pi divided by 2 pi times 2, which is 4 pi. And now pi and pi cancel out, and this just leaves us with 2 units. So given this information, we just figured out that at this specific instant in time, the radius of the circle has to be 2 units. So these examples that I have done, they're pretty simplistic. So these kind of related rates examples are probably the most simple ones that you would find. But now let's go ahead and move to something slightly more tricky. So this is a very common type of related rates problem. So here what we have is that we have a wall and the ground, of course, and we have a ladder. This diagonal line of length 13 is the ladder. And we know that this ladder is sliding down the wall. So x is increasing and y is decreasing. So this ladder is sliding down the wall. And I'm going to write out some information. So let's say that the x value, the length of the bottom edge of this ladder from the wall, let's say that value is increasing at a rate of 5 units per second. 5 units per second. All right? And then let's say that at a specific instant in time, x has a length of 12 units. So now what I want to do is I want to find at what rate is y decreasing. How fast is the ladder sliding down the wall? Like how fast is this vertical distance of the top of the ladder from the ground decreasing at this specific instant in time? And I encourage you to pause this video and try to do this one out on your own. Alright, I'm assuming you've given this a try, and now I'm going to go over how to do this problem. So the first thing we have to do, as always, is to write an equation. Let's write an equation using x and y's. And so put them in the same equation so that we have a relationship expressing those two variables together. So how do we go ahead and do that? Well, the first thing you have to recognize is that this is a right triangle. Right? This is a right triangle. So we can use the Pythagorean theorem. What that means is that x squared plus y squared is going to equal 13 squared, which is 169. So I'll just write that down. X squared plus y squared has to equal 169. So now all these variables, x and y, are changing with respect to time. So let's go ahead and differentiate both sides. So I'm going to differentiate both sides with respect to time. If I do that, this gives me 2x times dx dt plus 2y times dy dt is going to equal the derivative of time, the derivative with respect to time of 169. Well, 169 is just a constant, and the derivative of any constant is 0. So 2x times dx over dt plus 2y times dy over dt is going to equal 0, right? So now we have a new relation. We have x and dx dt plus y and dy dt. So what I'm going to do is that I'm going to move this 2y dy dt over to the other side. So we have 2x dx dt is going to equal negative 2y times dy dt. Like that. So now let's try to go ahead and solve for dy over dt. So let's plug in our given information. We know that x is 12. So 2 times 12. And then we know that dx dt is equal to 5. Dx dt is equal to 5. And now we want to solve for dy dt. But we have a problem. We don't know what y is, do we? We don't know what the value of y is. Well, the value of y can be easily found like this. So we know that at a specific instant in time, the value of x has to be 12 units, right? So if the value of x is 12 units and the length of this ladder is constant at 13, we can use the Pythagorean theorem to figure out what y must be. At the specific instant in time. And I could do the math on this one, but I think an important thing you should know is that the 12, 5, 13 triangle is a common Pythagorean triple. So if the length of one leg is 12 and the hypotenuse is 13, that means that y would have to be 5 units long. So let's plug that in. 2 times 12 times 5 is going to equal negative 2 times 5. Y is going to equal 5. And then we want to solve for what dy over dt is. So now let's go ahead and solve. So dy over dt is going to equal 2 times 12 times 5 over negative 2 times 5. So 5 and 5 will cancel out. 2 and 2 will cancel out. So all we have now is a negative 12 units per second. So here's another very common related rates problem that you might see in your calculus class. So here we have an inverted conical funnel. Let's call it a funnel. And it's filled with water, but there's a hole at the bottom. So this water is draining out of this cup. And so we're given some information about the cup. The cup is in the shape of a cone. So the base radius is 5 feet, and the total height of the cone is 14 feet. And we know that the volume, the water is draining out at a rate of 2 feet cubed an hour. And here's what we want to find. When the depth of the water in this cup is 6 feet, how fast is the depth of this water? How fast is the depth of this water decreasing? So let's go ahead and see how we might solve this problem. So the first thing I want to do is that let's write an equation first. So we want to write the equation for the volume of a cone. The volume of a cone is equal to 1/3 pi r squared h. And notice that all we want is the rate at which h is changing with respect to time. So we don't want this radius in here. So how can we replace the radius with something that's in terms of height? So what we have to do is that we have to write the radius of the cone. We have to write the radius of the cone in terms of the height of the cone. So how do we do that? Well, notice that all this entire cone, the radius is 5 feet and the height is 14 feet. So what that means is that the ratio of radius to height is going to be 5 to 14. So what that means is that 14r is equal to 5h. So let's see if we can solve for r. If I solve for r is equal to 5 over 14h. So what I'm going to do is I'm going to replace r with 5 over 14h. So let's go ahead and do that. So the volume is going to equal 1/3 times pi. R is 5 over 14h squared, and you multiply that all by h. So let's go ahead and rewrite this a little bit. So 1/3 times pi, 5 over 14 squared is 25 over 196 times h squared times h, which is h cubed. So I went ahead and rewrote this expression a little bit. 1/3 times 25 over 196 is equal to 25 over 588 times pi h cubed. Now, let's go ahead and differentiate both sides with respect to time. So we have that dv dt is going to equal 25 over 588 multiplied by pi times 3h squared dh dt. I just use a chain rule over here. So if I rewrite this, dv over dt is going to equal 25 times 3 is 75. 75 over 588 times pi h squared times dh over dt. So now let's go ahead and plug in our values that we were given. So dv over dt is equal to -2, right? dv over dt equals -2, and that has to equal 75 over 588 times pi. And we know that the depth at which we were talking about at the specific instant in time is 6 feet. So 75 over 588 times pi times 6 squared multiplied by dh dt. And now let's solve for dh dt. So dh dt is going to equal -2 divided by 75 over 588 times pi times 6 squared. -2 divided by 75 over 588 times pi times 6 squared. And to evaluate this, we can use a calculator. So let me input this quickly into a calculator. So we have -2 divided by 75 over 588 times pi times 6 squared. And what this gives us is an answer of -0.139 feet per hour. So what this means is at this specific instant in time, the depth of the water in this funnel is decreasing at a rate of 0.139 feet per hour. Let's go ahead and do one more example. So here we have an intersection. So here's my best drawing of an intersection, and we have two cars. There is car A. Let's call this car over here car A, and car B. This is car number B. And both of these cars are moving toward each other on this intersection. They're both moving towards each other. And let me write some information down. Let's say car A is moving towards the intersection at 30 meters per second. So dy by dt is equal to -30 meters per second. And let's say that car B is moving towards the intersection at 20 meters per second. So dx by dt is equal to -20 meters per second. And let's say that at some instant in time, car B is 60 meters away from the intersection. And let's say at that same instant in time, car A is 80 meters away from the intersection. So what I want to find is this. I want to find that at this specific instant in time, when car B is 60 meters from the intersection and car A is 80 meters from the intersection, at this specific instant in time, how fast is the distance between the two cars changing? So let's think about how we would go about solving this particular problem. And to facilitate our understanding, I'm going to draw a quick right triangle. So let me draw a right triangle real quick. Okay, so here is our right triangle, and here is our right angle right here. So this vertical leg, I'm going to call it y. This horizontal leg, I'm going to call it x. So let's pretend that this point over here is the intersection, and x is the distance of car B from the intersection, and y is the distance of car A from the intersection. So what that means is that the hypotenuse of this right triangle is going to be the distance between the two cars, and let's call that distance r. So now we're ready to go ahead and write an equation. So let's go ahead and write an equation for this. So we're going to use the Pythagorean theorem. So what that means is that x squared plus y squared is going to equal r squared, like that, right? And now let's go ahead and differentiate both sides with respect to t. So if I differentiate the left side, I get 2x dx dt plus 2y dy dt is going to equal 2r dr dt, like that. And what I want to find is I want to find what dr dt is, right? So let's solve for dr dt. So dr dt is going to equal 2x dx dt plus 2y dy dt all over 2r. So let's go ahead and start plugging in values so we can solve for what dr dt is. So dr dt is going to equal 2, and at that specific instant in time, we know that x is 60 meters, right? So let's go 2 times 60, and we know that dx dt is negative 20. So that's negative 20 meters per second, like that, plus 2 times y. What's y at a specific instant in time? Y is 80 meters, right? So y is 80. Y is 80. And then dy by dt at this instant is negative 30. Like that. Negative 30. And now we have to divide all this by 2 times r. Well, what is r at this instant in time when x is 60 and y is 80? Well, for this one, we can go ahead and solve for r using the Pythagorean theorem. So we know that x squared plus y squared is going to equal r squared. So we know that x is, let's see, x is 60, so that's 60 squared plus 80 squared has to equal r squared. So r is going to equal the square root of 60 squared plus 80 squared. And if I solve this, r is going to equal, let me use a calculator real quick, the square root of 60 squared plus 80 squared is equal to 100. So r is going to equal 100. So let's plug in 100 for r over here. So here is our expression for dr dt. It's going to equal 2 times 60 times negative 20 plus 2 times 80 times negative 30 divided by 2 times 100. And let's see what all this comes out to be. So we have 2 times 60 times negative 20 plus 2 times 80 times negative 30, all divided by 2 times 100. And that comes out to negative 36 meters per second. So at this specific instant in time, when car B is 60 meters from the intersection and car A is 80 meters from the intersection, at the specific instant in time, given the speeds of the car, the distance between the two cars is decreasing at a rate of 36 meters per second. So there are a series of steps that you can use to help you solve related rates problems. So the first step is always draw a diagram. Always draw a diagram, because when you draw a diagram, that helps you visualize what you're trying to do better. After drawing a diagram, write down what you know. This is also a very essential step. Write down what you were given. If you know the rate at which the volume is changing, write that down. If you know the length of the side of a square at a certain length, at a certain instant in time, write that down. Make sure you write down what you were given so that you have all your information in one place. And if you have all your information in one place, that will make the process of solving these kind of problems much easier for you. Then step 3, set up an equation. This is kind of self-explanatory on why you need to do that. You have to set up an equation so that you have a relationship between the variables that you are dealing with. Then differentiate both sides. Then differentiate both sides. Once you differentiate both sides, you will get you'll get an equation that you can use to plug in values and then solve. So these 5 steps are essential to solving related rates problems. But if you follow these 5 steps, you should be able to do these with no problem.